Thank you again, Theo. It's very nice to be here and to talk about work. It's always inspiring to meet other people and discuss work. I was particularly interested in all the questions that you kind of published on the web page. And there are lots of interesting questions there. And I said to Theo that I would actually enjoy answering them in a written form. So that's something that I think I'd like to do. But of course, after this lecture, we will have some time to discuss either those questions or new questions that come up during the talk. But the title of the talk is called Creative AI in Our Hands, Playing with Intelligent Instruments. And I use hands here because a lot of the creative AI that we are faced with today is all based on machine learning and some kind of textual prompting to the results. You type in something and you get a picture, or you get a poem or a sound or text of some sort. And it feels a little bit disembodied. It feels one-sided. It's a dialogue, but it's not an embodied dialogue. What we are trying to do with this project that I'm going to introduce is to have that dialogue in our hands. You know, musical instruments are and have always been conversation partners of some sort. But when they become intelligent, with intelligent algorithms, there's something that changes. And this is the topic that I want to explore with you today. So I have to tell you, this is a European Research Council funded research. It's a ERC consolidated grant, and it's hosted at the University of Iceland. And what I wanted to kind of explore a little bit is how I came to work on this grant or write this proposal and design this research project. So I've always been really interested in materiality, material anthropology, and how we think with the objects that we use, whether it's pens or instruments or anything, any devices. And here on this slide, we can see three types of instruments: the acoustic instruments, the electric instruments, and the digital. And I've been interested in analyzing a little bit in the past the phenomenology of working with these instruments. There is a certain kind of natural connection that we have with the acoustic instruments, where the interface and the resonating body is the same thing. The energy that you put into the instrument is the same energy that comes out. There's no trickery going on. It's very natural. And very often you are touching the instrument where the action is happening. For example, in flutes or violins or guitars and so on. Although there are instruments which have a bit of a mapping, like the piano or the church organ, harpsichord, where there's this kind of a mechanism between your fingers and the resonating body or what generates the sound. And all that changes with electric instruments. Suddenly there is energy coming out of your instruments that is not the energy of your body, but the energy that comes from electricity. And so you can really amplify and make very loud sounds. And this, of course, has changed the way we think about instruments, the way we perform, and so on. Suddenly, for example, the guitar became part of ensembles or bands, jazz bands, for example. But before electricity, it was simply too soft. It wasn't loud enough to be part of it. And of course, today we have still symphony orchestras and so on. But why do we have all these violins? It's because you needed more loudness. Of course, it gives a certain texture to the sound to have 20 violins or something as well, but it's primarily loudness that they were seeking. And then with digital instruments, you can see how the mapping becomes completely arbitrary between the instrument and the sound. Any algorithm can be written into the interface, and you get some kind of break, a cut between the interface and the sound engine, which is different from the acoustic and the electric in many ways. And this is very exciting. There's a whole research field around this, often called NIME, New Interfaces for Musical Expression, where people are investigating making new instruments, how it feels to play them, the philosophy behind it, the phenomenology of working with them, and so on. So this is kind of a background to a lot that I've been thinking and developing, for example, live coding languages as extensions of the mind, instruments, to think about code as an instrument. And the book that Theo referenced is this one, Sonic Writing. I was interested in creative AI in music, and I felt that I had to kind of explore a little bit music as or material systems as inscriptions for music making. And when you start to look at the past of music technologies, and when I say music technology, it's everything we use to make sound with, a bone flute is music technology, a violin is a music technology. So when you start to look into our current music technologies and you follow their histories back in time through a genealogy, you can see that we have material inscriptions, like technologies that have followed us for millennia in the way that we design our instruments. And the music theory is basically based on those material inscriptions. When you drill a hole into a flute, you are kind of defining the scale and the music theory of that flute and the culture around that flute, and maybe a culture of a whole tribe. So all these material design decisions are always musicological, they're always music theoretical, and they are compositional in many ways. So we could talk about composing instruments. I also talk about symbolic inscriptions in the book, which are in our history mainly following the invention of symbolic systems like writing systems, notation systems, and so on. So here we're maybe talking about a 4,000-year-old history where we can see some signs written into material. And some of those signs from early on have been about music, musical scores, and so on. But it's interesting how the idea of the musical score has developed over time. It's mainly through maybe the Gutenberg press that we start to get an industry around music, where the printed score becomes a format, a music format, a product that could be sold and distributed. And it's at that time where we start really to get the idea of the composer and the kind of author idea of where people signed their compositions and so on. A lot of the music in earlier ages were not assigned to a composer, but it was folk music. And then I also analyze in the book signal inscriptions, which is basically something that is only 100 years old, to record sound as a signal onto a medium and that's the wax cylinder, vinyl, tape, wire, and such devices. And signal inscriptions are, of course, also in digital systems where we write the signal as discrete numbers. And we also operate algorithms on it, for example, spectral analysis and such stuff. So you can see all of these things are what is founding the way that we make music today. And the last sentence on this slide is really kind of a challenge, really, because in the 21st century, we've had AI in music since the 50s. The first computer music composed was using Markov models, which is generative creativity. It is machine learning in a sense. And that's 70 years old. But it's really now in the 21st century that this AI is starting to become seriously challenging for the field of music. And that's something we can talk about later. But when I wrote the book, I finished it, I think, late 2018 or something. We had quite a lot of symbolic AI, creative AI, which was based on symbolic AI. It was a little bit of machine learning and going back decades, actually. But we didn't have the technology, we didn't have the algorithm, the speedy processors, and the data to train all this stuff. So it's really in the past 10 years that this revolution in machine learning that we see today started. And in 2018, it was in the periphery. And that's kind of interesting because I knew it was coming. I was following the development, but it wasn't something that I wanted to write about in this book. So this book is kind of the background for me. It's kind of drawing the landscape, the picture, to be able to see what is coming and to have the instruments and tools and kind of analytical tools to be able to understand what is coming. And so that's really the I'm going to jump over that slide, but that's really what we're doing in our Intelligent Instruments Lab, this project that I'm running now. We are interested in looking at the relationship with intelligent instruments when we design into physical instruments, into the body of physical instruments, algorithms that have agency, intelligence, and some kind of goal behavior, and to see how people respond to that, what kind of language comes out of that, what is the discourse, how do people feel about it, and so on. So we designed the project into 3 work packages. The first one we call the self, but that's kind of a phenomenological approach where we study how people relate to their instruments. The second work package is more sociological, dealing with other people, and it's kind of inspired by Latour and actor network theory, in that you include non-humans into the sociology. So it's a sociology of humans and non-humans, and the intelligent instruments become part of that sociology. So we're looking at kind of agencies as they emerge in relationships. And the third work package that we just started this year is on knowledge. We are looking at how we can apply intelligent instruments to study data, big data. So this is an epistemological work package. We are interested in if instruments can help us to understand large data sets through sonification, for example. not only, but that's a good example, but also through multimodal display, and to be able to engage with data through the haptic devices that we are building in our lab. So that really opens the lab up to all kinds of scientific approaches, not based necessarily on music, but I think music is a good platform for scientific research in many, many ways. So I always like showing this picture. It's in my book, Sonic Writing, but I find it so inspiring in that this is from the 17th century, where scientists were starting to do empirical research on the world. And for that, they needed tools and instruments of science. And people like Bacon talked about how the instruments become extensions of the mind, extensions of the body, in order to understand better how the world works. For example, a scale, you can weigh things better than with your hand. So they were using all these instruments to understand the world. And if you look closely to the right of this picture, you can see there are instruments there, an harpsichord, cello, Thor maybe, or what is it called? Trombona marina, I think it. Trombona marina, this long instrument that reaches into the window. And I quite enjoyed thinking about this picture, in that these instruments are scientific instruments. They're musical instruments, of course, but they're applied in science. I don't think they're there just because the scientists want to take a break from their work and jam a little bit and then go back to work. I think it's part of their research to study things that Pythagoras was studying from early on, you know, things like ratios and vibration and mathematics of the string, for example. So we have been building our own type of wall like this. We call it the organium, and it's where we explore and build new instruments from all kinds of sensors. We augment physical instruments. So last weekend, for example, we had a flute workshop here in our lab, and we built flutes and we added electronics to the flutes, which became quite interesting. And for us to explore our ideas about agency and intelligence and what kind of language derives from it, we really have to work with people and work with different traditions. We try to be music agnostic. We're not kind of focusing on any particular style of music. And we collaborate with all kinds of people as much as possible. And through those collaborations, we learn so much. It's incredible how many new ideas just come from discussions in our lab, or collaborations, or requests by users what they want to do. So we started our project in 2021 in September, and we thought, okay, let's start with the most basic thing of all music, the technologies, the string. And the string obviously is something that Pythagoras again was exploring, the monochord, and we thought we would try to make a string instrument that was based on the technology of the haldorophone. I'll show you a little bit of the haldorophone later, but it's an instrument designed by the technician in the lab, and it has been used or marketed or produced in many copies And for example, Hildur Guðnadóttir, the composer, she used it in the movie called The Joker, and she won Oscars for that work. And so you can hear the particular sound of the halduraphone, which is a feedback instrument. And we applied that technology in these string instruments here. But of course, it so happens that we have a string instrument like this in Iceland. It's called the langspil. And it's an old instrument, folk instrument. It was kind of put into the periphery when new instruments came into the country, like violins and pianos and harps and so on. But it existed all around the country, and people played it a lot. And there's still this tradition in the country, and we were interested in trying it out and collaborate with these people. And then, of course, we have problems, or we have to be careful. What does it mean that we start to take that instrument, copy that instrument, and add electronics to it, and call it langspil? We weren't sure, so we contacted people in the community of langspil players, and they were very interested in this, and they came and worked with us. And in the final result of that really was that they just found it fantastic that their instrument, that is still kind of in the periphery of Icelandic musical culture, that it was being kind of looked at from a modern technology lab, kind of embraced and given attention, new design, and of course collaboration. So that is kind of a case where we had to be careful of not being guilty of cultural appropriation, you know that term, to take someone else's culture and just make it your own, and not understanding the source of that culture, and not even understanding the music of that culture, or musicology, or intentionality of that music, but to really work with people and learn from them and collaborate with them and feed back into that culture and point to that culture. So immediately when we started this work, it became an experiment in humanities as well, and sociology, these ideas of cultural appropriation, and to explore how people engage with such intrusion into their own culture, really. So we haven't had any negative feedback on that yet. Of course, some people just think it doesn't sound any interesting. It's a feedback instrument. So a lot of people are not into feedback for many reasons, and they just think it's a weird thing. But they're not criticizing it, or the making of it as a theft or things like that. So what we do, because instead of working 5 people in a lab in our ivory tower doing weird research and coming up with our own ideas, we really want to work with people. And this is very much in tune with what is called today citizen science, or community engagement, societal engagement, or public engagement. These are different terms that people use in various ways. They do not necessarily mean the same. But we want to work with people. We want to understand what we're doing through collaboration. And for that reason, we have every Friday, we have an open lab. We open our doors at 3 o'clock, where people come and have coffee and present their work. And we have had people coming to explore our work and take it further, build something new from it. for example, in the top row here, you can see how the long spill was made into a Eurorack. We actually did design it as a Eurorack device. It fits into the typical modular synth racks, and we were interested in, you know, having audio going in and out, and so you would have a natural kind of physics as part of your modular synths. But our collaborator David, he made a much more advanced system here. As you can see, it's a beautiful instrument, and it is a Eurorack long spill for feedback. And then we've invited all kinds of people, luthiers, designers of all types, to work with us and test materials. We, for example, worked a lot with e-textiles because we were in a department where, or in a school where we had textile designers and also product designers. So looking a lot into products, HCI, and different materials that become part of the way that we design intelligent instruments. Here, for example, we're exploring seaweed as a material, and we had a very interesting workshop on that. Yeah, there's a video here, and I could show you a little bit, for example, as an example of the open lab. This is e-textiles, and so Sophie Skach, she made textiles for us that are conductive, so you can touch it and you get electricity flowing through them. And in this experiment here, it's being connected to a no input mixer. But it was such a beautiful project because, for many reasons, to work with different community of people, textile designers, they came with so many interesting ideas into our lab. And to work together in the lab like this, I mean, we discovered so many interesting things, like it's not the pressure on the textiles, it's the conductivity of the human body that really makes a difference here. We, for example, did an experiment with a hard kind of, I don't know if I have it here. No, it's a kind of a stick that you press on, and you didn't feel any difference. A wooden stick wouldn't do much. But then when you pressed with your finger, it changed. And even the e-textile designer wasn't so sure why that was, but obviously when you start to think about it, it's about the wetness of the finger and the conductivity and so on, and maybe the ground as well. But these kind of things often come up with in the experiments where people are around. At one point, the textile itself became a theremin, so you could just kind of sculpt the sound above the textile itself. And that was totally accidental as well. Definitely not a design goal. It was something that we discovered. And we have tried to reproduce that a few times. And in one of those times, we couldn't reproduce it. So we're kind of still figuring out how it worked. But it's easy to do, though. It's easy to reproduce the kind of theremin aspect of it. But there's another thing with this as well. If you think about musical instruments, and in particular digital musical instruments, they are made of plastic. They have glass screens, maybe metal knobs. They look very much like some kind of a control board of a spaceship or something. You know, it's very hard and cold interfaces in many ways. And what we found when we looked at the phenomenology of this e-textiles and we started making sculptures and instruments with them, that suddenly the instruments are warm, you know, at least you at least you don't feel anything cold when you touch it. I mean, if I just touch my phone here, it's cold. The glass is cold, but the textiles are not. And it's fluid and it's kind of flexible, and it's not signifying precision. You know, the slider here, I have a MIDI controller, and you know, it's got all these numbers, and it's kind of connoting precision. But the e-textiles are not doing that. They are opening up for exploration and intuition, to kind of navigate rather than to go for a set goal. So there's so many things that happen just by changing the material, and also to connect that to AI, then to intelligent algorithms. That's really interesting. And the whole discourse around this became very, very fruitful for us and useful. All of this is part of what I call in sonic writing a change in musical practice, maybe in new music practice, where in the past, maybe coming from Romantic times, I mean, this was not the case in Baroque music, for example, but with Romantic music, you have this idea of the composer, the genius, often a well-off white European male, you know, some kind of a genius that is inspired by the muses and composes a work. The work with a capital W, you know, l'oeuvre or obra or whatever, ergot. And the work is some kind of a metaphysical manifestation of something. And then you have interpreters interpreting the work, and they're kind of slavishly trying to interpret the intention of that great composer. This is changing. If you go to modern musical contexts, concerts, festivals, and so on, you very often find composers and performers that are inventing their own systems. They're making systems to play with, and the system is almost the work. The art is in the system, and they're composing the system or inventing. I say inventing here because I'm also thinking about the rhetorical, the medieval times rhetorical term in invention, which is what Bach was doing when he wrote all his inventions, like variations of a theme. But we are inventing systems, and then those systems become something that we explore. We're inventing kind of spaces to explore in new musical work. And I think it has something to do with who we are as a culture, people, generations. I mean, most of us grew up with computer games. And in computer games, we enter a world and we navigate that world and we explore it and so on. And that's different from reading a book in many ways. Although the exploration when you read the book is a lot in your head, but the piece is different. The nature of the piece is different. And so that kind of non-linearity and exploration, I think, is very natural for our generation. And also the technology that we have today kind of affords it. It invites us to think in those terms. So I want to show you a little bit of videos. One of the instruments that we like exploring is called the chalaparta, and it's a Basque instrument from the Basque country. And it is a traditional instrument where two players always play against each other, and it's a kind of a call and response performance. They take turns, but they do it really fast, and it's really virtuosic to watch people play it. But we were interested in, since it's time-based patterns, we were interested if we could train a neural network model with the patterns of the players, and if we could then simulate a human player and then explore how it feels. And here is a video from an early example. So this is Enrique Hurtado, and he has been collaborating with Yvonne Arge, who is also a chalaparta player. And we trained it on lots of rhythms that they had recorded, also with their collaborators. But we trained it on a model called notochord, which was already trained on 100,000 MIDI files and rhythms. But then we trained the chalaparta on top of that. So there was a lot of knowledge in the model already. And then when they came to Iceland, we trained it on their playing. And what was really interesting is how their kind of ghost was in the model. We were not able to, I mean, I could not play it in the same way as they played it. And the model responded much better to them than they did to me, even if I know how to play the chalaparta a little bit. So there's a sense in which the technology becomes very honed into a particular person or a particular data set. And we are currently investigating how we might, for example, train it on different people and maybe have a drop-down menu where you can select who you're playing with. So you select the ghost of the person that you are playing with. And it also caused problems, for example, for novices, because these guys are really good and it's trained on really good performances. But when you then get a novice banging on it, the model doesn't have a clue how to respond. And it poses a problem for us. How do we make a system where the novice can learn through the system and become a good performer? And this is something that we're exploring at the moment. But what you see here is symbolic data in a machine learning model. So it's discrete events in time series that the model is learning. But we're also interested in neural audio synthesis. And this video here shows an interface that Nicola Privato has made. And it's made out of magnets. He's very much interested in the kind of ghosts of these systems. So he's looking into neural audio synthesis, and the kind of ghosts of the people that whose model he has trained on, but also kind of how he controls those models. And I'm going to play a little bit of that. In this video, Nicola has trained a neural audio model, neural audio synthesis model on the sounds of the equipment and when he was building it and so on. But he can equally use models with choirs or guitars or saxophones or whatever the model has been trained on. And what he's got in his hands are these magnetic controllers, and he is sending out 8 streams of data, which are connecting to 8 parameters in the latent space of the model. So he's kind of navigating. If you imagine the neural audio model as a balloon that you blow up with when you train it with sounds, he's kind of navigating his way through those sounds, and he can find interesting areas within there. He can find other interesting areas, and then he can play through. And then we've got interactive machine learning mapping algorithms that enable him to maybe zoom into certain interesting areas in the model and kind of jump from one interesting area to another rather than navigating areas that are less interesting. So Nicola, he also built this magnetic interface. It's called Stacko. It's got 4 magnetic sensors underneath these circles, and then he's using magnetic balls, and they basically work like joysticks. You can see how the ball goes up and you can move it around and you can get X and Y data very easily. But what becomes more interesting is when you move it around with your hands, you move it sideways and you kind of, and it's really an interesting interface to explore neural audio models. It's almost like the perfect interface for that, because you have so much control, so many parameters, and you quickly start to kind of get an idea of what the audio model is doing. And he's been doing workshops with this, with people, making scores for it, magnetic scores, and people have been building all kinds of things just to try to get people talking about this stuff and try to understand it and share it. And there are people who are building their own versions of the Stacko around the world. Yeah, I did mention the Haldoraphone. This is the instrument by Halldór Úlfarsson. I tend to think of it as a famous instrument, but many of you might never have heard about it. That's because I'm in a bubble, of course. But it's a feedback instrument, and at the bottom of this instrument, there's a speaker, and you can see 5 pickups underneath the string. Sorry, 4 pickups underneath the strings and 4 on the resonating strings underneath here as well. And then the 5 sliders. Each slider is for the pickup, the gain of each pickup, and then general gain. So you can really control which string is feedbacking. You can control how they interact with each other. So it becomes a really interesting dynamical cybernetic system, this instrument. And it's beautiful to play it. You know, you really feel that the instrument is alive. It's almost like an animal. It has a certain agency that you're in a dialogue with. And we've been doing experiments with this. We've been building an intelligent Haldoraphone with embedded signal processing. We use Bella as part of the instrument. But for neural audio synthesis, we use our laptops. It's not fast. The Bella is not fast enough for it. But then we have a breakout board, and we can take the signal out into our sound card and feed it back in. And we have been doing experiments with people. We had Adam Pultz-Melby with us, who did a really interesting study on how experienced Haldorophone players understand and perform with an instrument, with an AI kind of Haldorophone. And we looked into different types of algorithms, how people perceive different algorithms. And we investigated the perception of agency in the instruments. So here is a video, for example, where Julia Mogensen is playing the Haldorophone in a concert. And what was interesting with Julia's performance was that she is a very, very good cellist, trained cellist, and she felt that she didn't want to play this instrument so much. She didn't want to impose her own playing onto the instrument. She was more interested in the instrument kind of speaking on its own, and she was just facilitating the intentionality of the instrument itself. We found that very interesting, and other players have expressed something similar. And in many ways, we connect it with developments in kind of post-human theory, where people are becoming a bit tired of big artistic egos and maybe into exploring things, exploring the environment or the relationships with the environment. And here we find a really good example, a physical example of that happening. We've also been working with Marco Donnarumma, and he is kind of an artist who is an expert in prosthesis, in bodily extensions. And he worked with us on a piece that he did in Germany on a workshop with deaf people or hard of hearing, where they started to listen to the world through their bodies, not with the ears necessarily. And for that, they used resonators and all kinds of haptic devices that would be put onto their body, and they could perceive the world. And the results of that were just fantastic. I was lucky enough to be part of the opening of it. I gave a talk, and there was a person before me who gave a talk that was entitled The Terror of the Prosthetic. So the fact is that a lot of the deaf people, they find the prosthetic a bit of an intrusion into their culture. It's as if they are supposed to be cured of something, but they have their own culture, they have their own language, they have systems to communicate. And many of them feel that this prosthetic is not necessarily helping them in their cultural being, you know, it's an intrusion. But they were very, very interested in different types of prosthetics to engage with the world and the world of sound, not necessarily through the cochlear ear, but through the body. And Marco did just fantastic work with them. I found it very interesting, where, of course, the idea of the prosthetic is kind of broken up a little bit. We look at it from philosopher Andy Clark's perspective that we're all natural-born cyborgs. The human beings have been technological beings, cyborgs, since the birth of humanity, really. We extend our bodies with instruments and tools. And we substitute, we have sensory substitution with technology. We amplify, we reduce the world through all kinds of technologies. And here's a little clip of Marco's piece. So he had on his body kind of 3D printed ears that were connected to the body through magnetism. But then he was able to take it off and give it to people in the audience, and people would really hear partly his the inside of his body, but also the music through that. And it was a very interesting performance, I thought. And for us, it's just so beautiful to see how our technologies, what we're developing, how it's applied in artistic practice. Yes, I was just talking about this post-human intentionality, and this is Hildur, who has been performing on the Halldóraphone for over 10 years. And in many ways, the way she talks about the instrument, I guess you can find lots on YouTube. You can find her talking in very interesting ways about the relationship with the instrument. Talking about feedback, I just had a message that Till Boveman was here, and he said hello. He is also probably on your side. He's the kind of expert on feedback, I guess, if you want to catch him somewhere in the corridor and ask him about all these things. So what we're trying to understand and investigate are these ideas of agency. We are not trying to define them necessarily so strongly. There are lots of definitions. You have the definitions of actor network theory, where objects become actants, or they have agency. And that's a kind of description of agency that maybe the biologist would not subscribe to necessarily. They're more interested in agency of kind of living beings, how a being has a membrane, how it digests, how it kind of makes offspring, how it has a goal towards something. And that becomes some kind of an agency for them. And then, of course, you have the agency of the philosophers, whereas, at least in Anglo-American philosophy, you would see agency as defined as something of a logical, kind of reasonable being that takes decisions based on logic, So that's a very different types of agency, and we're not trying to define it. We're just exploring the area and see how people describe their interactions with the instruments. And the same goes for intelligence. Today, artificial intelligence is often just, people mean machine learning with it, but there are all kinds of artificial intelligences, you could have analog computers, you could have symbolic AI, you could have artificial life, all kinds that are not necessarily trained neural networks. And then we have intelligence everywhere, in humans, plants, animals, and computer systems. So it's really interesting to open up these concepts and break them up and explore them from empirical research, from contextual research. But in general, what we are really trying to think of and understand is how artificial intelligence becomes a prosthetic of the mind, how we are in this generative dialectics with the AI, where embodied and hermeneutic relationships become dialectic relationships. You already are doing it, of course, if you use ChatGPT or Midjourney or something. You're already in a relationship dialogue with the AI. But we're interested in it in a real-time performance physical instruments context, and to understand that conversation that happens. This agential other. And I can say a lot of the performers that we play with, the musicians that play our instruments, they often talk about the instrument as a trio, or the relationship that happens as a trio. So it's themselves, it's the physical instrument, the thing that vibrates and with strings or a flute or whatever, and then it's the algorithm. And the agency of the algorithm. So that becomes kind of a trio, but then at other perceptions, it becomes one as well. You know, you become one with the instrument, and the instrument is integrating. So this connects with what a lot of people are nowadays calling entanglement. There's a lot of focus in human-computer interaction into entangled design, and it relates to that. But I'm gonna finish now because it's 2 o'clock for you, I think. And in short, I just want to talk about music as a fantastic platform for research into the future. And I was looking into the etymology of music when I wrote my book, and of course I find that Plato was doing the same. He was looking at the etymology of music, and he finds that it comes from the muses. We knew that, of course, but what he's saying is that the muses derive the word comes from making philosophical inquiries. So musicking is to explore. To music is to go into the unknown and do inquiries. And I find that a beautiful kind of quote to end on, because in many ways, music is just a fantastic platform to do research, because we have the artistic, we have the engineering, we have the embodied, we have the social, we have the performance, but also the practice, the commercial product. You know, it's endless perspectives on what music is. And then the science of music, the mathematics, the sound, the psychoacoustics, and so on. So I think I'm going to end here, Theo, and maybe we should open this up for a discussion.